Saturn is usually introduced as the peaceful one, the elegant planet, the patient one, the one that sits quietly at the edge of the visible solar system wearing its rings like jewellery. In photographs it looks almost polite. Soft gold bands, thin shadows drifting across the rings, a pale globe hanging in black silence. No explosions, no lava oceans, no screaming storms like Jupiter's great red spot. Just a calm world, beautifully balanced, slowly turning in the cold. For a long time, that image has survived almost untouched. But the strange truth is this. The more closely we study Saturn, the less peaceful it becomes. Because Saturn is not frightening in the way people expect. It does not threaten with fire, it does not glare with violence. It waits. And the longer you look, the clearer something unsettling begins to appear behind the beauty. The rings are not ornaments. The sky is not gentle. And the planet itself is not a place you could ever stand. Saturn is a world built almost entirely out of things a human body cannot negotiate. Pressure, speed, distance, and time. The calm picture hides a machine. A slow one, a patient one. But a machine all the same. And if you were somehow placed there, even briefly, the elegance would disappear almost immediately. Because the first thing Saturn takes away from you is something so basic we almost never notice it on Earth. Ground! Saturn is the second largest planet in the solar system, nearly 10 times the diameter of Earth. But unlike Earth, or Mars, or even Mercury, it has no solid surface. There is nowhere to land. No rock, no ice plain, no crust waiting under the clouds. Only atmosphere, layer after layer of gas and fluid, thickening slowly as you fall. From a distance, the cloud tops look like a surface. Your eyes want to treat them like one. But they are not. They are weather, a floating skin of ammonia clouds and hydrogen haze drifting thousands of kilometers above the deeper atmosphere. And if you arrived there in a spacecraft and began to descend, something quiet but important would happen. The planet would not stop you. There would be no moment of impact, no ground rushing up, just a long, continuous sinking. At first it might even feel gentle. Saturn's gravity is actually weaker at the cloud tops than Earth's gravity at sea level. You would feel almost comfortable. The sky around you would glow a pale yellow. Light from the distant sun would filter through thin atmospheric haze. The rings might still be visible above you, a thin blade of silver crossing the sky. And the air outside your hull would be almost silent. But the calm would not last. Because Saturn's atmosphere is not still. It is moving. Constantly. Jet streams race around the planet at speeds that make Earth's strongest hurricanes look like slow weather. Winds on Saturn can exceed 1,800 kilometers per hour. Faster than a rifle bullet. Fast enough that if the atmosphere were thick enough to hear clearly, the sky would never stop roaring. But high in the upper atmosphere, the gas is thin. The violence hides behind quiet. And that quiet is one of Saturn's most convincing illusions. From millions of kilometers away, the bands of colour seem smooth, elegant stripes wrapped around the planet, but each band is a river of wind, a moving wall of atmosphere circling the world again and again. Saturn rotates once every 10.5 hours. For a planet almost 10 times wider than Earth, that is an astonishing speed. The equator is moving more than 9,800 meters every second. Imagine standing on a world where the horizon itself is racing sideways faster than a jet aircraft. Now imagine that world has no ground, only weather. The deeper you descend, the more the pressure rises. At first slowly, then faster. The clouds above you would thicken. The light from the sun would dim. Yellow would turn to amber, amber to rust, rust to something closer to twilight. And still you would be falling. Because Saturn is not structured like a layered cake with clear boundaries. There is no clean line where atmosphere ends and planet begins. Instead, the gas simply grows denser. Hydrogen becomes compressed. The pressure climbs from 1 atmosphere to 10 to 100. At around the pressure you would feel 1 kilometer under Earth's oceans. Saturn's atmosphere has already become too dense for an aircraft to fly through safely. And below that point, the descent becomes something else entirely. Not flight, not falling, more like sinking into a fluid that slowly stiffens around you. The hydrogen thickens. Helium drifts deeper. The temperature begins to rise again. Because Saturn may sit almost 1.4 billion kilometers from the Sun, but deep inside the planet, heat is still leaking outward from its formation. Saturn actually radiates more energy than it receives from sunlight. The planet is slowly cooling from its birth, and that internal heat feeds the atmosphere above it, driving storms, driving winds, driving motion that never fully stops. If you kept descending long enough, the pressure would become overwhelming, thousands of times stronger than the air pressing on your body right now. Your spacecraft hull would begin to groan, metal flexing, structure compressing. Eventually, hydrogen itself begins to behave differently. At pressures millions of times higher than Earth's atmosphere, hydrogen atoms are squeezed so tightly together that electrons begin to move freely between them. The gas becomes something strange. Liquid metallic hydrogen, a substance that conducts electricity like a metal but flows like a liquid. Deep inside Saturn, entire oceans of this exotic material slowly circulate, and those moving oceans help generate the planet's magnetic field, a magnetic shield stretching millions of kilometers into space, a silent cage of invisible force. But almost no human imagination ever travels that far into Saturn, because the image we carry is still the distant one, the beautiful one, the rings. And the rings are perhaps Saturn's most persuasive lie. Seen through a telescope, they look delicate, almost fragile, a thin halo of light surrounding the planet. They feel permanent, timeless, as if Saturn was simply born that way. But those rings are not solid structures. They are not sheets. They are not even stable in the long term. They are debris, trillions of pieces of ice, fragments ranging from dust grains to boulders the size of houses, all orbiting Saturn in a flattened disk hundreds of thousands of kilometers wide, each fragment moving at tens of thousands of kilometers per hour, and each one obeying gravity with perfect precision. From a distance, they look smooth. Up close, they are a swarm, a blizzard of frozen shards racing around the planet in endless loops. No air, no sound, just motion. And that motion is controlled by Saturn's gravity with ruthless efficiency. Some particles are shepherded into narrow lanes by tiny moons. Others collide and shatter. Others slowly spiral inward toward the planet. In fact, Saturn's rings are slowly disappearing. Gravity and atmospheric drag are pulling material down toward the planet in a process scientists sometimes call ring rain. Ice particles vaporize as they fall into the upper atmosphere. The rings are dissolving, not quickly, but steadily. Estimates suggest that within about 100 million years, Saturn may lose most of its rings entirely. In cosmic terms, the rings might be temporary, a brief phase in the planet's long life, which means the Saturn we see today might exist in a very narrow window of time, a moment when the debris is still visible, a moment when the beauty has not yet faded, but that beauty is built on wreckage. Something broke apart to create those rings. Perhaps a moon torn apart by tidal forces, perhaps a captured object shredded by gravity. Whatever the origin, the rings are not decoration, they are remains, and Saturn has been carefully arranging those remains ever since, keeping them suspended, sorting them, grinding them down, slowly feeding them back into the planet that created them. From far away, Saturn looks like peace, a quiet ornament hanging in the dark. But every layer of that picture begins to collapse when you approach. There is no surface. There is no stable weather. There is no silence once you understand the motion. Even the rings are temporary. The calm image survives only because distance hides the mechanism. Up close, Saturn is not peaceful. It is patient, and patience, in a system this large, can be far more frightening than violence. The color is the first thing that misleads you. From far away, Saturn looks warm, not blazing like the sun, not volcanic like Jupiter's red storms, just a quiet wash of gold and cream, as if the planet has been painted in old sunlight. Telescopes reinforce the illusion, photographs soften it even further. Saturn becomes a pale lantern floating in black space. But the color is lying to you, because that gold does not come from warmth. It comes from chemistry drifting in extreme cold. High above the planet, sunlight strikes a haze of ammonia crystals and complex hydrocarbons, molecules assembled slowly in the upper atmosphere by ultraviolet radiation. The light scatters through those particles. The clouds glow, And from 1 billion kilometers away, the planet looks almost gentle. But Saturn's average temperature near the cloud tops hovers around minus 180 degrees Celsius. Cold enough to freeze the air in your lungs solid. Cold enough that metals grow brittle. Cold enough that exposed skin would not simply burn with frostbite, it would stiffen. Quietly, almost immediately, the sun at Saturn is already weak, only about 1% as bright as it is on Earth. Daylight there would feel more like a heavy twilight. The sky never becomes fully dark, but it never becomes bright either. Light arrives diluted, thin. The planet sits so far away that sunlight takes about 80 minutes to reach it, and by the time that light spreads across Saturn's enormous atmosphere, it has lost most of its authority. The clouds glow softly, but they do not warm. They cannot, and yet Saturn refuses to freeze into stillness, because the planet carries its own heat. Deep inside, Saturn is still slowly releasing energy left over from its formation more than 4 billion years ago. Helium droplets fall through the hydrogen interior like rain. As they sink, gravitational energy converts into heat. The planet warms itself from within. Not violently, but steadily. This quiet internal heating stirs the atmosphere above it, and that stirring becomes weather. At first the clouds look smooth, bands of pale yellow and cream wrapping around the planet in wide, elegant stripes. But those stripes are not patterns painted on a sphere. They are flows. Entire rivers of atmosphere sliding around Saturn at extraordinary speeds. One band moves east, another moves west, each layer slipping past the next. If you were hovering just above the cloud tops, the sky would not appear calm at all. The atmosphere would be racing sideways faster than anything humans normally associate with wind, 1,800 kilometers per hour. That is faster than the speed of sound on Earth, faster than most fighter jets, and yet the gas itself is so thin in the upper atmosphere that the violence hides behind a strange stillness. You would not hear a hurricane. You would see motion, the clouds beneath you stretching and folding as they stream across the planet's curved horizon. Long filaments pulled into ribbons, storm cells opening like pale wounds and slowly sealing again. Every 10 hours, Saturn spins once on its axis, a massive world rotating faster than intuition believes possible. At the equator, the atmosphere is being carried sideways at almost 10 kilometers every second, and the clouds respond. The equator bulges outward. The planet is visibly flattened. Saturn's diameter across the equator is nearly 10% wider than its diameter from pole to pole. It is not quite spherical. It is stretched, like a spinning drop of liquid trying to escape its own gravity. That shape tells you something important. Saturn is not rigid. It cannot be. The planet is too fluid, too dynamic, too restless beneath the clouds. You are not looking at a stable surface. You are looking at a skin, a shifting membrane of weather riding above a much deeper ocean of gas. And the deeper you go, the stranger the sky becomes. At the uppermost level, ammonia crystals form thin white clouds. Below that, the temperature rises just enough for ammonium hydrosulfide to condense. These clouds sit deeper in the atmosphere, darker and heavier. Even farther down, water clouds begin to form. Yes, water, but not gentle rain clouds like the ones drifting over Earth. These clouds exist under crushing pressure. The storms that erupt within them are enormous. Lightning flashes detected by spacecraft have revealed bolts thousands of times more powerful than those on Earth. A single Saturnian lightning strike can release energy comparable to a small nuclear explosion. And when those storms erupt, they grow enormous. In 2010, astronomers watched one such storm expand across the planet. It began as a bright disturbance in the northern hemisphere. Within weeks, it stretched around the entire circumference of Saturn. A planetary storm belt. Imagine standing on Earth and watching a hurricane grow until it wrapped completely around the globe. Saturn does this occasionally. Not every year, but often enough that the planet seems to breathe with storms. The atmosphere builds tension for years. Then something breaks. The clouds tear open. Lightning rips through the darkness below, and the storm spreads outward until the entire latitude band becomes turbulent. Then the atmosphere calms again. The sky smooths out. The elegant stripes return. From far away, the planet looks peaceful again. But the calm is only temporary. The system underneath never stops moving, and if you are still descending through those clouds, the illusion would continue to unravel. Because the deeper you go, the less the atmosphere resembles anything familiar. The light fades first. Sunlight cannot penetrate forever. The deeper clouds absorb it, scatter it, turn it into a dim amber glow that slowly collapses into darkness. At some point, the sky above you would disappear entirely. The rings would vanish. The sun would vanish. Even Saturn's famous stripes would dissolve into shadow. Your instruments would become your only window. Pressure outside the hull climbs steadily. 10 atmospheres. 20. 50. At 100 atmospheres, the pressure would equal the force of the ocean 1 kilometer beneath Earth's surface. The atmosphere now behaves less like air and more like a heavy fluid. Every motion becomes harder. Drag increases. Your descent slows. And the temperature begins rising again. This is one of Saturn's quiet betrayals. The upper atmosphere is brutally cold, but deeper down, the trapped heat from the planet's interior begins to dominate. The environment grows warmer, then hot, all while the pressure continues climbing. The deeper atmosphere becomes thick and murky. Hydrogen compresses. Helium separates. Cloud layers form and dissolve in complex chemical cycles scientists are still trying to fully understand. And still, there is no surface. No floor, only a continuous gradient from thin sky to crushing fluid. The planet never announces where it begins. It simply thickens until the idea of falling through air no longer makes sense. You're sinking into something closer to a sea. And that realization breaks another quiet assumption people carry about planets. We imagine planets as places, landscapes, surfaces waiting to be explored. Saturn refuses that idea entirely. It is not a place you visit. It is a system you enter, a depth, a gradient, a pressure well so vast that human categories, sky, ground, weather, start losing their meaning. Even the color that welcomed you from afar fades away down there. The gold sky disappears. The atmosphere becomes dim, then dark. The warmth becomes oppressive. And the winds, though slowed by the thickening fluid, continue to move enormous masses of gas around the planet. Saturn never truly stops circulating. Its atmosphere is too large, too energetic, too deeply connected to the heat below. From space, it still looks calm, a quiet banded sphere wrapped in delicate rings. But that picture survives only because distance hides scale. And Saturn's scale is the real threat, because every layer of the atmosphere you descend through is thicker than the one before. Every kilometer adds pressure. Every kilometer steals light. Every kilometer commits you further to a direction that has no reversal. You cannot stand. You cannot stop. You cannot climb back out without enormous power. Saturn does not fight you. It simply keeps going. Layer after layer. Sky after sky. Until eventually the idea of a sky stops making sense at all. And you realize something unsettling. The planet's beauty was never the calm. It was the distance. The gold color. The soft bands. The quiet rings above. They were never signs of peace. They were signs that you were still very far away. Your instincts still expect a landing. Even after everything Saturn has already taken away, warmth, sunlight, silence, some quiet part of your mind keeps waiting for the moment when the descent ends. Planets are supposed to have surfaces. Rocks, ice, something that pushes back. Something you can stand on. Saturn never does. And that is where the fear begins to sharpen. Because the longer you descend, the more obvious the truth becomes. You're not approaching a place. You are entering a depth. The clouds above you close like a ceiling. The pale gold sky that welcomed you from orbit fades into a dim rust-colored haze, then into a brown twilight that seems to absorb the last traces of sunlight. The rings are gone now. The sun is gone. Above you is only thickening cloud. Below you is pressure. And the fall continues. Not dramatic, not violent, just persistent. Saturn is enormous, so large that the cloud tops themselves sit thousands of kilometers above the planet's deeper interior. But the atmosphere does not end abruptly. There is no clear boundary where sky becomes ocean or gas becomes ground. Instead, the descent simply grows heavier. The air thickens. The molecules crowd together. Hydrogen, normally the lightest, most delicate element in the universe, begins behaving differently when billions upon billions of atoms are forced closer and closer together. Your instruments would show the pressure climbing steadily. 5 atmospheres, 10, 50, 100. On Earth, 100 atmospheres of pressure is what you would experience nearly a kilometre beneath the ocean's surface. Down there, steel hulls begin to creak, glass domes implode. Even thick submersibles are operating at the edge of survival. But Saturn's atmosphere does not stop there. The pressure continues to rise. 200 atmospheres, 500, 1,000. Outside your vessel, hydrogen and helium are no longer behaving like thin gas drifting through empty sky. They behave like fluid. Your descent slows as the atmosphere pushes back. Not enough to hold you up, just enough to remind you that the environment is changing shape around you. And still there is no ground. This is the moment Saturn truly stops resembling a planet. Because the word planet carries assumptions built on Earth. We imagine gravity pulling us down toward rock. We imagine mountains and plains waiting beneath the sky. Saturn breaks that expectation completely. The deeper you fall, the less meaningful the word surface becomes. Cloud layers dissolve. New chemical reactions appear. Temperatures climb. At around 200 kilometers below the visible clouds, the temperature may already be approaching 300 degrees Celsius. Hotter than molten lead. Yet the pressure is so enormous that hydrogen and helium remain compressed into dense fluid rather than boiling away. It is a strange inversion of environments we understand. Above you is deadly cold. Below you is crushing heat. But both exist within the same atmosphere, and Saturn never pauses between them. If your spacecraft was strong enough to survive the pressure, and almost nothing humans have built could, your descent would eventually reach one of the strangest transitions in planetary physics. Hydrogen begins to change its identity. Normally, hydrogen atoms keep their electrons tightly bound. But under extreme pressure, millions of atmospheres, the atoms are squeezed so closely together that the electrons start moving freely between them. The fluid becomes electrically conductive. Not a gas anymore. Not quite a solid either. Something stranger. Liquid metallic hydrogen. Imagine an ocean made not of water but of compressed hydrogen acting like a molten metal. Thick. Conductive. Slowly circulating deep within the planet. Inside Saturn, that ocean may extend for tens of thousands of kilometers. A vast interior sea hidden beneath the clouds. No waves. No shoreline. Just enormous currents moving silently through a world of crushing pressure. And those currents generate Saturn's magnetic field. Because when electrically conductive fluid moves inside a rotating planet, it creates magnetism. The effect stretches far into space. Saturn's magnetic field reaches outward in a vast invisible bubble, deflecting solar particles and shaping radiation belts around the planet. From space, that field feels like protection. But down here, deep in the interior, it is a reminder that Saturn is not static. The entire planet is moving, circulating, converting gravitational energy and heat into endless internal motion. And the deeper you go, the less recognizable anything becomes. Pressure climbs into the millions of atmospheres. Temperature climbs into thousands of degrees. The hydrogen ocean grows denser. Somewhere far below, scientists suspect Saturn may contain a core of heavier elements, rock and ice compressed into an exotic mixture under unimaginable pressure. But even that idea is uncertain, because Saturn is not a simple layered sphere. The interior is probably mixed. Gradients of density rather than neat boundaries. Heavy materials dissolving into lighter ones. Fluid regions blending slowly into each other over enormous depths. In other words, even if there is a core, it may not feel like one. There may never be a moment where the descent clearly ends. Only thicker material, greater pressure, more heat, until eventually your spacecraft would fail. Not dramatically. No explosion. Just a gradual surrender. Metal fatigues. Seals rupture. Structure bends. The pressure outside is simply too great. Saturn does not crush you out of anger. It crushes you because physics leaves no alternative. And that is what makes the planet so unsettling. There is no violence in the usual sense. No volcanoes erupting. No asteroid impacts raining fire. just a continuous environment that becomes less survivable with every kilometre. A system so large and patient that it never needs to hurry. Even the storms above you, those enormous lightning systems and jet streams, are only surface expressions of something deeper. The entire planet is circulation, energy moving outward from the interior, atmosphere responding, clouds forming and dissolving, and everything slowly rotating together. Once every 10 hours, Saturn spins faster than intuition allows for something so vast. That rotation stretches the planet outward. The equator bulges. The poles flatten. The entire world becomes slightly squashed. You would not notice it while falling through the atmosphere. But from space, the shape is unmistakable. Saturn is not round. It is pulled outward by its own motion, a spinning ocean of gas trying to balance gravity against centrifugal force. And the faster it spins, the more the atmosphere organizes itself into bands, rivers of wind circling the world, storms forming where flows collide, eddies spreading slowly across the planet's face. The weather is not random. It is structured, ordered by rotation, and that order hides a deeper truth about Saturn. The planet is not chaotic. It is controlled. Gravity holds the atmosphere in place. Rotation organizes the winds. Pressure compresses the gases. Heat from the interior drives circulation. Everything follows the same quiet rules, which means that if you fall into Saturn, nothing unexpected happens. No sudden event stops you. No dramatic transition marks the boundary. The environment simply continues becoming less compatible with life. And that slow progression may be the most unsettling thing about the planet, because it removes the moment when you might fight back. There is no single disaster, just a sequence of conditions that grow steadily worse. Colder sky, darker clouds, rising pressure, increasing heat, thickening atmosphere, until eventually the planet stops feeling like a sky you are falling through, and starts feeling like a depth you cannot escape. Saturn does not need a surface to be dangerous. In fact, the absence of one may be the most frightening thing about it, because without ground, there is no boundary, no place where the environment stops becoming more extreme, no horizon where survival stabilizes, only the quiet certainty that the deeper you go, the more the planet belongs to physics rather than possibility, and somewhere far above, beyond tens of thousands of kilometers of cloud and pressure, the rings are still shining in the sunlight. From that distance, Saturn still looks peaceful, a golden world surrounded by a delicate halo. But the rings never see what lies beneath the clouds. They only circle the planet, endlessly, like a warning drawn in ice. Eventually, the descent stops feeling like falling, not because you reached anything resembling ground, but because the atmosphere around you is thickened so much that the word air stops making sense. You're no longer moving through sky. You're moving through something closer to liquid. The hydrogen and helium pressing against your hull behave less like drifting gas and more like a slow, heavy ocean. Your speed drops as the drag increases. The planet itself is quietly absorbing the energy of your fall. Outside, the pressure continues climbing. 2,000 atmospheres. 5,000. 10,000. Numbers like that are hard to imagine, but the translation is simple. The pressure pushing on your spacecraft now is stronger than the weight of entire mountains pressing down on a single square meter of metal. On Earth, deep-sea submersibles reach perhaps 1,000 atmospheres before engineering begins to reach its limits. Saturn has barely begun. The hull would start talking. Not loudly, just a long metallic groan, stretching through the structure like a slow complaint. Bolts tightening against their threads. Panels flexing inward by fractions of a millimeter. Every material has a point where strength becomes negotiation, and Saturn specializes in negotiation. It does not deliver a sudden catastrophe. It just keeps adding weight. Above you, thousands of kilometers of atmosphere now press downward. Below you, the density continues increasing as hydrogen atoms crowd closer together. The temperature climbs steadily. 400 degrees. 600. 800. This is the strange betrayal of Saturn's environment. The upper atmosphere was brutally cold, but deeper down, the trapped heat of the planet's birth begins to dominate everything. Gravity squeezes the interior. That compression generates heat. Helium droplets sink slowly through the hydrogen interior like rain falling through a strange sky. Each droplet releases gravitational energy as it descends, and that energy has nowhere to go except outward, upward into the atmosphere, powering circulation that has been running continuously for billions of years. Saturn is still cooling from the violence that created it. You are falling through a world that remembers its birth. The deeper you go, the more the atmosphere resists you. Hydrogen molecules pack tighter. The fluid thickens. Your descent slows to something almost graceful. You are no longer dropping. You are sinking. Imagine drifting downward through an ocean where every meter becomes heavier than the one before. No waves, no currents you can see, just a quiet pressure field tightening around you. The light is completely gone now. Not dim. Gone. Sunlight cannot penetrate this far. Above you lies a roof of cloud layers thousands of kilometers thick. Below you stretches an interior that has never seen daylight in the history of the solar system. The only illumination comes from instruments and faint internal glow from the heated atmosphere. And somewhere in this depth, hydrogen begins crossing a threshold that physicists once believed could exist only inside stars. The pressure reaches millions of atmospheres. Atoms compress. Electrons detach. Hydrogen changes phase. It becomes metallic hydrogen. Not solid metal, not liquid metal in the familiar sense, but a dense electrically conductive fluid where electrons move freely between atoms. A metallic ocean made of the simplest element in the universe. It does not shimmer. It does not reflect light, but it carries electric currents across enormous distances. And those currents are what create Saturn's magnetic field. Deep below the clouds, the planet is running an enormous dynamo. The metallic hydrogen slowly circulates as Saturn rotates. The moving conductive fluid generates magnetic lines of force that expand outward into space. Invisible architecture? A magnetic cage stretching millions of kilometers around the planet. From orbit, that field protects Saturn from solar wind and channels charged particles into radiation belts. But here, deep in the interior, the magnetic field is just another symptom of motion. Saturn never sits still. The entire planet is moving inside itself. Currents sliding around currents. Heat rising. Helium sinking. Hydrogen compressing. Every process unfolding on scales so vast that human time feels almost irrelevant. Your spacecraft is now surrounded by a fluid environment hotter than a blast furnace and denser than the deepest parts of Earth's oceans. Yet the pressure continues rising. 2 million atmospheres. 5 million. 10 million. At these depths, matter begins behaving in ways that barely resemble the chemistry we know. Hydrogen merges into metallic phases. Helium separates and rains downward. Heavy elements dissolve into the surrounding fluid. Saturn is no longer a planet with atmosphere. It is a gradient, a slow transition from sky to metal. And somewhere deeper still, perhaps 20 or 30,000 kilometers below the cloud tops, scientists suspect a core of heavier material may exist. Rock, ice, elements left over from the earlier stages of planet formation. But even that idea is uncertain, because under pressures like these, the meaning of rock or ice becomes strange. Water becomes superionic fluid. Minerals dissolve into hydrogen. The boundaries between substances blur. The interior may be less like a solid core and more like a thick stew of compressed elements slowly mixing over billions of years. If the descent could continue, which it cannot for anything humans have ever built, your spacecraft would eventually reach the limits of structural endurance. Not because of impact. There is still no ground. But because pressure and heat together simply erase the possibility of structure. Metal weakens. Electronics fail. Seals rupture. Eventually the hull collapses inward. Saturn closes around you. Not violently. Just completely. And yet, in a strange way. None of this is the most unsettling part. The crushing pressures, the metallic oceans, the interior heat, those are dramatic, but they are also distant from our everyday imagination. The deeper discomfort comes from something much simpler. Saturn never gave you a moment to resist. There was no cliff edge, no volcano, no explosion. Just a continuous descent through conditions that slowly stopped caring whether you could survive them. Earth is filled with boundaries. Ground, shorelines, atmosphere ending in space, places where one environment clearly stops and another begins. Saturn has almost none. Its layers blur. Its transitions stretch across thousands of kilometers. The planet does not confront you. It absorbs you. And while all of this unfolds far below the visible clouds, the planet's most famous feature is still quietly circling above. The rings. From the depth of Saturn's interior, those rings would feel unimaginably distant. Hundreds of thousands of kilometers away. A thin disk of ice fragments orbiting silently around a planet whose true body lies buried beneath tens of thousands of kilometers of atmosphere. From orbit, they are delicate. From the surface of a moon nearby, they would glow like a pale blade cutting across the sky. But here, deep inside Saturn's pressure well, the rings are something else entirely. Evidence, because rings do not form around peaceful planets. They form when gravity tears things apart. Moons break. Comets shatter. Debris spreads outward into orbit, and Saturn gathers those fragments into the most beautiful wreckage in the solar system. From far away, the rings look like decoration. From closer inspection, they begin to resemble something else. A record, a history written in ice, a reminder that Saturn's calm face hides a system that sorts, shreds, and rearranges entire worlds. And that realization leads to a deeper question. If Saturn can dismantle moons, what else is it capable of shaping? Because the planet itself may not be the scariest thing in this system. Saturn has a family, a collection of worlds orbiting within its gravity. And some of those moons carry wounds that Saturn itself may have helped create. The rings were only the beginning. By the time you understand Saturn's weather, the word calm has already stopped working. From orbit, the planet's atmosphere looks organized. Bands, stripes, soft gradients of cream and gold. It resembles a painting, but those bands are not decoration. They are rivers. Entire jet streams of atmosphere racing around the planet, each one flowing in the opposite direction of the next. Eastward winds sliding against westward winds. Vast lanes of gas moving in parallel across a world almost 10 times wider than Earth. From a distance, the pattern feels elegant. Up close, it feels mechanical. Because every one of those bands is powered by forces too large to ever switch off. Saturn rotates once every 10 hours and 33 minutes. For a planet nearly 120,000 kilometers wide, that rotation is astonishingly fast. The equator spins through space at more than 9 kilometers per second. That motion drags the upper atmosphere with it. The result is a system of jet streams that circle the entire planet like conveyor belts of wind. Some of them stretch for tens of thousands of kilometers without interruption. No continents break them. No mountains slow them. No oceans disrupt their path. Just endless lanes of moving sky. If you hovered above Saturn's clouds long enough, you would see the bands sliding past one another like giant rotating gears. And in the places where those gears grind together, storms are born. On Earth, storms feed on heat from warm oceans. They weaken when they move over land. Eventually they burn themselves out. Saturn has no land, and its storms do not run out of ocean. They feed on atmospheric motion and heat rising from deep within the planet, which means they can grow larger, last longer, and move in ways Earth's weather never could. Some of Saturn's storms expand until they circle the entire planet. These events are known as Great White Spots. They appear roughly once every Saturnian year, about 30 Earth years. For decades the atmosphere seems calm. Then suddenly a brilliant white disturbance erupts in the clouds. Lightning tears through the storm. Convective towers punch upward through multiple atmospheric layers, and the system begins spreading sideways. Week by week, the disturbance stretches across the planet's latitude. Thousands of kilometers, then tens of thousands. Eventually the storm wraps all the way around Saturn. Imagine a hurricane forming in the Atlantic Ocean and growing until it surrounded the entire Earth like a glowing belt. That is the scale Saturn operates on. And the lightning inside those storms is not subtle. Spacecraft listening from orbit have detected radio bursts from lightning bolts powerful enough to dwarf anything our planet produces. Each discharge may release thousands of times more energy than a lightning strike on Earth. For a brief moment, enormous volumes of atmosphere are heated to temperatures hotter than the surface of the sun. Then the flash fades. The storm continues moving. and Saturn's sky slowly rearranges itself again. But the winds never stop. Even between the storms, the jet streams continue racing around the planet. Some exceed 1,800 kilometers per hour. That is faster than the speed of sound in Earth's atmosphere. On our planet, winds like that would strip cities apart. But Saturn has no buildings, no forests, no oceans to churn into waves. The wind simply moves gas. Entire rivers of atmosphere sliding endlessly across the face of the planet. And that movement shapes Saturn's appearance in a way that is almost hypnotic. Each band has its own chemical makeup. Different temperatures, different cloud heights, ammonia crystals reflecting pale sunlight, ammonium hydrosulfide clouds drifting deeper below, water clouds hidden in the darker atmosphere beneath them. The layers interact, rise, collapse, shift sideways. The result is the striped world seen through telescopes. But those stripes are temporary. The atmosphere rearranges itself slowly. Storms leave scars in the bands. Jet streams drift. Cloud layers thicken and thin. Over decades, the entire planet subtly changes its face. And yet one thing never changes. The motion. Because Saturn's weather is not powered only by sunlight. In fact, sunlight barely matters this far from the sun. Most of the energy driving the atmosphere comes from the planet itself. Saturn radiates almost twice as much energy as it receives from the sun. That excess heat comes from the slow gravitational settling of helium inside the planet's interior. Tiny droplets of helium form within the hydrogen ocean and sink deeper into the planet. As they fall, they release gravitational energy. That energy becomes heat. And that heat rises through the atmosphere, quietly fueling circulation across the entire planet. Saturn's storms are not seasonal accidents. They are symptoms of a deeper engine, a system that has been running since the solar system was young. And that engine does not care whether anyone is watching. If you are somehow floating in Saturn's upper atmosphere, high enough to avoid the crushing pressures below, you would still experience something profoundly alien. The sky would be dim, the sun a distant pale disk. The winds would carry you sideways across the planet at unimaginable speeds, and the horizon would stretch outward in a perfect curve for thousands of kilometers. There would be no land, no landmarks, only moving clouds, and the occasional birth of something enormous, a disturbance forming somewhere along a band, a brighter patch, a rising plume, then lightning, then expansion, a storm assembling itself across a world so wide that the curvature of the planet becomes visible beneath the cloud decks. And as it grows, the rest of the atmosphere would respond. Jet streams bending, cloud bands rippling outward, the entire planet adjusting to a new disturbance in its endless circulation. Saturn does not treat storms as disasters. They are simply how the system releases pressure, how energy escapes the depths below, and when the storm finally fades, the atmosphere closes again. The bands smooth out. The colors soften. From a distance, the planet looks peaceful once more. But now the illusion has been damaged. Because once you know how the atmosphere moves, how the winds race, how the storms spread, how the heat from deep inside keeps the entire system alive, the beauty of Saturn begins to feel different. The calm image no longer reads as serenity. It reads as scale. The planet does not need dramatic explosions. It does not need violence that appears sudden or loud. Its weather operates on a scale so vast that the violence becomes invisible from far away. A hurricane that wraps around a world, lightning flashes brighter than continents, jet streams faster than aircraft, and all of it hidden inside those quiet golden bands. The sky looks smooth because the forces shaping it are too large for the eye to notice from orbit. Saturn does not advertise its storms. It lets distance soften them. And while those winds continue circling the planet, something stranger waits at the top of the world. At the North Pole, a shape that should not exist. A storm system so precise that it forms a perfect geometric figure in the clouds. 6 sides, 6 enormous walls of moving atmosphere. A structure that has remained stable for decades. Perhaps longer. A storm shaped like a hexagon. And the deeper scientists looked into Saturn, the clearer it became that the planet was not merely chaotic. It was organized in ways no one expected. The weather was not just powerful. It was precise. If you drift far enough north through Saturn's atmosphere, the bands begin to tighten. The wide golden lanes that circle the middle of the planet grow narrower. The winds begin to twist. And eventually the striped pattern collapses into something no other planet in the solar system possesses. A shape. Not a vague spiral storm like the ones on Jupiter, not a circular hurricane like those on Earth. A polygon? 6 sides. Perfect enough that the eye recognizes it instantly. At Saturn's north pole, a gigantic jet stream organizes itself into a hexagon roughly 30,000 kilometers across, wide enough to swallow the entire Earth. Each side of the hexagon is longer than the distance from New York to Los Angeles, and the structure has remained stable for decades, possibly far longer than that. The first time humans saw it clearly was in images returned by the Voyager spacecraft in 1981. At first, scientists assumed it might be a temporary storm pattern. Saturn's atmosphere is chaotic, after all. Weather systems should shift, dissolve, reform. But when the Cassini spacecraft arrived in orbit around Saturn in 2004 and began sending back detailed images of the North Pole, the hexagon was still there. Still rotating, still maintaining its strange geometry. A 6-sided river of wind circling the pole at speeds of about 300 kilometers per hour. And inside that hexagonal wall, another storm turns. A polar vortex. A hurricane-like system nearly 2,000 kilometers across, with clouds spiraling down toward the center like an enormous cosmic drain. Lightning flashes inside it. Winds scream around its perimeter. But the vortex does not break the hexagon. The two systems coexist, one spinning inside the other, and that is where Saturn begins to feel less like a familiar planet and more like a machine running on rules we're only beginning to understand. Because nature almost never produces clean geometric shapes at planetary scale. Clouds swirl, storms stretch, weather breaks symmetry. Yet here, Saturn maintains a shape so precise it looks almost artificial. 6 straight edges, 6 corners where the winds bend sharply before racing off along the next wall. From space, the hexagon appears like a massive trench carved into the atmosphere, a border between two kinds of weather. Inside the boundary, the clouds churn violently around the pole. Outside it, the banded atmosphere continues its endless sideways flow. The hexagon is the line between them, and no mountain or continent is responsible for that boundary. There is nothing solid beneath it, only fluid atmosphere. The secret lies in the wind itself. The hexagon is created by a powerful jet stream that circles the pole. That jet stream is unstable. It wobbles slightly as it flows. But under certain conditions, a jet stream can settle into a standing wave pattern, like vibrations traveling around a circular track. Instead of remaining smooth, the jet develops repeating bends. Those bends can lock into place. On Saturn, the wave stabilized into 6 repeating curves. 6 bends around the pole, which gives the jet stream its hexagonal shape. It is not a structure made of clouds. It is a pattern made of motion. The clouds simply reveal it. If you could hover above Saturn's north pole and look down, the atmosphere beneath you would appear to rotate slowly like an enormous wheel. The hexagon would slide past below you, each side stretching thousands of kilometers. The winds along its walls move fast enough to carry you across Earth in a matter of hours. And yet the shape holds. Saturn's atmosphere bends the wind but refuses to break the geometry. It is an eerie sight, because it feels deliberate, like a design. But it is not. It is simply physics unfolding on a scale so large that our instincts no longer trust it. And the longer scientists studied the hexagon, the stranger it became. Cassini's instruments revealed something subtle. The hexagon does not stay perfectly fixed relative to Saturn's surface. It drifts slightly. It oscillates. And the clouds within it change color over time. During Saturn's long seasons, each lasting about 7 Earth years, sunlight slowly returns to the pole. When Cassini first arrived, the northern hemisphere was still deep in winter. The hexagon appeared dark blue, almost black, but as the seasons shifted and sunlight returned, chemical reactions in the upper atmosphere changed the color of the clouds. The hexagon turned gold, then pale amber. The same chemistry that paints Saturn's equatorial bands slowly repainted the polar storm, which means the hexagon is not static. It breathes with the seasons, slowly changing while the shape remains locked in place. And the seasons themselves are long here. Saturn takes nearly 30 Earth years to complete a single orbit around the Sun. Winter darkness can last for years. During that time, the North Pole sits in shadow. The hexagon continues spinning in darkness, unseen by sunlight. Cassini had to wait patiently as the season shifted, watching as the sun slowly climbed back above the horizon. For the first time in human history, scientists watched the polar storm awaken into daylight. And when it did, the hexagon was still there. Still sharp, still enormous, still impossible looking. But what makes the hexagon unsettling is not only its geometry, it is what that geometry implies. Because maintaining a shape like that requires stability, a deep underlying order. The winds along the jet stream must maintain their speed. The atmosphere beneath must remain structured enough to support the standing wave. Saturn's atmosphere is not random chaos. It is controlled chaos. Every jet stream tied to the planet's rapid rotation, every storm interacting with pressure gradients and internal heat, every cloud layer responding to the physics unfolding thousands of kilometers below. The hexagon is the atmosphere briefly revealing that hidden order. Like a ripple pattern appearing on the surface of water, a visible signature of forces deeper than the clouds themselves. And that realization makes the storm feel different. Because storms on Earth feel temporary. They arrive. They destroy. They leave. But Saturn's hexagon may have been spinning for centuries, perhaps longer than modern science itself. A permanent weather system. A structure made of wind that refuses to dissolve. That kind of stability is strange, even unsettling, because it means the forces shaping Saturn operate on timescales far beyond human experience. The planet's atmosphere is not just active, it is persistent. Patterns survive, structures endure, and those patterns appear again in other places, in the rings, in the gravitational dance of the moons, in the way Saturn sorts motion and debris with silent precision. The hexagon is not an isolated curiosity. It is a hint, a glimpse of a deeper principle running through the entire Saturnian system. Order emerging from enormous forces, beauty produced by tension, structure appearing inside chaos, which means the hexagon is not the strangest thing Saturn has created. It is only the most visible one, because far beyond the North Pole, stretching outward for hundreds of thousands of kilometers, Saturn is shaping something even more delicate. Something that looks fragile, but exists only because gravity is doing something ruthless. The rings. And once you see what those rings really are, Saturn's elegance begins to look less like beauty, and more like aftermath. From a distance, Saturn's rings look impossibly delicate. A thin halo of light surrounding the planet, perfectly flat, perfectly balanced. They seem so precise that the mind wants to treat them like a structure, a solid disk, a graceful ornament. Something Saturn simply wears. But if you could move closer, close enough that the rings fill the sky, you would discover something unsettling. They are not solid. Not even remotely. They are a swarm. Trillions of individual fragments orbiting Saturn in an immense, flattened disk that stretches nearly 300,000 kilometers across. And yet, in many places, that entire disk is thinner than a mountain is tall, sometimes only 10 meters thick. From afar, the rings look smooth. Up close, they resemble a blizzard frozen in orbit. Chunks of ice tumble slowly past each other. Some no larger than grains of sand, others the size of boulders, some even as large as houses, each one following its own orbit around the planet, moving at tens of thousands of kilometers per hour. There is no glue holding them together, no solid surface connecting them, only gravity. Saturn's gravity pulls every fragment inward toward the planet, but their sideways orbital motion keeps them from falling. The balance between those two forces, gravity pulling down and motion carrying sideways, creates the rings. A delicate dance of physics that looks serene only from far away. Inside the rings themselves, the environment would feel strangely alive. Fragments drift together, touch, bounce, sometimes shatter. Tiny impacts occur constantly, but because everything is moving in nearly the same direction and speed, the collisions are often gentle. Two icy rocks brushing past each other in slow motion. A faint scrape, a muted crack. The sound would barely travel in the vacuum of space, but the motion never stops. every fragment adjusting its path in response to gravity and collision. And gravity here is not just Saturn's. Dozens of small moons orbit near the rings. Some pass close enough to shape them. These are called shepherd moons. Small worlds only a few kilometers across, but their gravity nudges ring particles into narrow lanes. They act like cosmic snowplows, keeping some regions clear, pushing particles into tight streams, carving sharp edges into the rings that should otherwise blur and spread over time. One moon named Prometheus repeatedly dives close to Saturn's ring. Each time it passes, its gravity pulls streamers of ice out of the ring like long fingers reaching toward it. Then the moon moves on. The streamers collapse. The particles scatter again. But the disturbance leaves scars. The ring remembers the encounter. Every orbit around Saturn takes place inside a gravitational battlefield. Tiny pushes, tiny corrections. A constant negotiation between motion and gravity. Which is why the rings contain so much structure. Thousands of individual ringlets. Gaps. Braided strands. Some regions packed with ice fragments. Others mysteriously empty. One of the largest empty spaces is called the Cassini division. From Earth, it looks like a dark split between two bright rings. But up close, it is not completely empty. Particles still move through it. They are simply scattered. A nearby moon named Mimas orbits Saturn at just the right distance to disturb those particles every time they pass. The gravitational resonance destabilizes their paths. Instead of staying in a stable orbit, the fragments drift away. Over time, the region becomes sparse. Saturn does not need to touch the rings to shape them. Its moons do the work. The entire system becomes a gravitational sculpture. Invisible forces organizing trillions of ice fragments into patterns that stretch across hundreds of thousands of kilometers. And yet for all their beauty, the rings are fragile. Far more fragile than the photographs suggest. Every orbit around Saturn slowly grinds the fragments down. Collisions chip away at the ice. Micrometeorites from deep space strike the rings and shatter particles into smaller pieces. Over time, some of that material drifts inward. Saturn's gravity pulls it slowly down toward the atmosphere. Scientists call this ring rain. Tiny fragments of ice spiral inward and vaporize when they reach Saturn's upper atmosphere. The planet is slowly eating its own halo. Measurements from the Cassini spacecraft reveal that this process is happening faster than expected. Saturn's rings may not last forever. In fact, they may not even be ancient. Evidence suggests they could be relatively young in cosmic terms. Perhaps 100 million years old, which means the spectacular rings we see today might not have existed when the dinosaurs walked on Earth, and they may not survive another 100 million years into the future. They are temporary. A phase. A brief moment in Saturn's long life. Which raises a question that makes the rings feel less like decoration and more like aftermath. Where did all that ice come from? Because rings do not assemble themselves from nothing. Something had to break. Something large. One possibility is that a moon once wandered too close to Saturn. Every massive planet has something called a Roche limit, a distance where tidal forces become strong enough to tear a celestial body apart. If a moon drifts inside that boundary, gravity pulls harder on the near side than the far side. The difference becomes catastrophic. The moon stretches, cracks, eventually shreds into fragments. Those fragments spread into orbit. Over time, they flatten into a disk. The rings. Another possibility is that a large comet or icy object from the outer solar system passed too close and suffered the same fate. Either way, the result is the same. The rings are not ornaments. They are debris, a shattered world slowly reorganizing itself under Saturn's gravity. Seen this way, the beauty of the rings becomes more unsettling. Every shimmering arc of ice is part of something that used to be whole. A moon broken apart. A body dismantled by tidal forces too powerful to resist. And Saturn did not have to do anything dramatic to cause it. Just gravity. Quiet. Relentless. The same gravity that holds the atmosphere in place. The same gravity that shapes the moons. The same gravity that sorted trillions of fragments into those delicate bands of light. Saturn does not explode worlds. It dismantles them slowly, piece by piece, and then it arranges the remains. Which means when you look at Saturn through a telescope and see that perfect halo of rings, you are not looking at decoration. You are looking at a process a machine that breaks objects down and redistributes the fragments, a system where beauty emerges from destruction, and the rings themselves are only the outermost expression of that process. Because Saturn's gravity extends far beyond the rings, outward into a vast family of moons, some small, some enormous, some scarred, some hiding oceans beneath thick shells of ice, and those moons carry clues about how Saturn's influence shapes entire worlds. The rings were formed from one broken body, but Saturn's system contains dozens of others, and some of them are stranger and more unsettling than the rings themselves. Once you understand that Saturn's rings are debris, the next question becomes unavoidable. Why do they stay there? With trillions of fragments constantly colliding, drifting, and nudged by gravity, the rings should slowly spread outward like smoke. Over time, the disk should blur, edges should soften. The beautiful sharp lanes should dissolve into a wide, faint cloud of ice. But they don't. Instead, the rings remain astonishingly organized. Thin, layered, almost surgical in their precision, which means something is controlling them, and that something is Saturn's gravity, not just its strength, its structure. Because Saturn does not simply pull everything inward, it sorts. Every fragment in the rings is trapped inside a complex gravitational choreography, where the timing of each orbit matters as much as the distance. A single icy particle circling Saturn might complete an orbit in about 7 hours. Another fragment slightly farther out might take 8. Another might take 10. Each one moving along its own invisible track. But occasionally those tracks line up in a special way. 2 objects might orbit Saturn in a perfect ratio. 2 laps of one fragment for every single lap of another. 3 for 1, 5 for 2. These relationships are called orbital resonances, and they can quietly destabilize an orbit. Imagine running around a circular track while someone else jogs slightly slower on the outer lane. If every few minutes you pass them in exactly the same place, the repeated gravitational tug slowly alters your motion. Tiny nudges accumulate. Over time, the orbit changes. In Saturn's rings, those nudges come from moons. Mimas, Janus, Epimetheus. Dozens of small bodies circling the planet in carefully spaced orbits. Each time a ring particle lines up with one of these moons, the moon's gravity pulls slightly on it. Most of the time, the tug is too small to matter, but in resonance, the tug repeats again and again at the same location. Eventually, the particle's orbit destabilizes. It drifts away. This is how Saturn clears out certain regions of the rings. Not by sweeping them physically, but by quietly making certain orbits impossible to keep. The Cassini division, the dark gap between Saturn's A and B rings, is largely shaped this way. The moon Mimas circles Saturn in such a way that any particle attempting to orbit within that region gets nudged repeatedly until its path shifts. The gap slowly empties. Saturn doesn't need to touch the ring. Gravity alone does the sculpting. But that same gravitational influence also creates something else. Edges. Some rings are confined so sharply that their boundaries look almost artificial. A thin bright line of ice ending abruptly against darkness. Those edges exist because of shepherd moons. 2 tiny moons, Prometheus and Pandora, orbit on either side of the F ring. Their gravity constantly pushes particles back toward the center. Any fragment drifting too far inward or outward gets nudged back into the lane. Like invisible fences guiding a cosmic highway, without those moons, the ring would spread apart in a few million years. Instead, it stays narrow, tense, almost braided, which means the rings are not passive. They are being maintained, a dynamic structure where trillions of fragments constantly collide, adjust, and reorganize under Saturn's gravitational rule. And that rule extends farther than the rings. Because gravity does not stop where the ice fragments end. Beyond the rings lies a region filled with moons. Some tiny, some enormous, each one moving through the same gravitational environment that controls the rings. Each one carrying scars from the same forces that shattered whatever created Saturn's halo. And those moons reveal something unsettling about Saturn's system. The planet does not merely hold objects in orbit. It reshapes them. Some moons survive intact. Others fracture. Some are stretched by tidal forces. Others are heated from the inside as gravity flexes their interiors again and again. Saturn's influence reaches into their cores. bending them, warming them, changing them over time, which means the rings are not the only remains orbiting this world. They are simply the most visible ones. Farther out, entire moons show signs that Saturn's gravity has been pulling on them for millions of years, stretching their interiors, cracking their surfaces, keeping them in constant motion. Saturn's gravity is patient. It rarely destroys anything instantly. Instead, it nudges, pulls, reshapes, orbit after orbit, year after year, until something breaks. The rings show what happens when gravity wins completely. But the moons show something even stranger, because some of them did not break. Instead, they changed. Under Saturn's constant pull, their interiors warmed, ice softened, water melted beneath frozen crusts, oceans formed, hidden worlds emerging inside bodies that should have been frozen solid. And suddenly Saturn's system stops looking like a graveyard of broken objects. It starts looking like something more complicated, because in some places, Saturn's gravity destroys. In others, it awakens. The rings are wreckage. But farther out, the moons begin to reveal something else. Entire environments shaped by the same invisible forces. And one of those moons, wrapped in a thick orange sky, carries a landscape that feels disturbingly familiar. Lakes, rain, rivers cutting across the surface. Except none of it is made of water. And the sky above it glows the same dim amber colour that once fooled us into thinking Saturn itself was peaceful. A moon called Titan, where Saturn's influence has produced something far stranger than debris, a world that almost resembles Earth, until you breathe the air. Up to this point, Saturn still feels like a single object, a planet with storms, rings made from wreckage, an atmosphere that refuses to end. But Saturn is not just a planet. It is a system. And once you widen the frame far enough, the real scale of that system becomes harder to ignore. Because the rings, the beautiful debris circling the planet, occupy only a tiny fraction of Saturn's gravitational reach. Beyond them, the space around Saturn is filled with moons. Not one or two, dozens. Small rocks tumbling through space, frozen spheres scarred by impacts, massive worlds large enough to hold atmospheres of their own. Each one moving along a carefully balanced orbit. Each one shaped, over time, by the same gravitational forces that sculpted the rings. From far away, Saturn appears solitary, a single golden globe with a halo, but in reality it presides over something closer to a family, a sprawling gravitational household stretching millions of kilometers in every direction. And like any family shaped by a powerful center, the moons carry marks of that influence. Some of those marks are subtle, orbital resonances quietly adjusting their paths, tidal forces slowly stretching their interiors, gravitational nudges rearranging their surfaces over millions of years. But other marks are much more obvious. Fractures, craters, hidden oceans, atmospheres that should not exist this far from the Sun. When you start to examine Saturn's moons one by one, a pattern emerges. Saturn is not just holding them, it is working on them. The same gravitational patience that shapes the rings extends outward into the moons themselves. Take a small moon like Mimas, barely 400 kilometers wide. From a distance it looks like a battered snowball. One enormous crater dominates its surface, so large that the impact nearly shattered the entire moon. The crater's walls rise like broken ice cliffs. Its floor stretches across half the moon's face. That single wound tells a quiet story about Saturn's system. Objects here do not simply orbit in peace. They collide. They fracture. Gravity pulls them into unstable paths until something eventually goes wrong. Mimas survived its impact. Barely. But other bodies may not have been so fortunate. Some could have been shattered entirely, turned into the fragments that eventually became Saturn's rings. Saturn's gravity does not protect its moons. It tests them, over and over. And the farther you travel from the rings, the stranger the moons become. Some are irregular lumps of ice and rock. Others are nearly spherical worlds large enough to have geological histories of their own. One moon, Iapetus, carries a bizarre two-tone surface. Half of the moon is dark as charcoal, the other half bright as fresh snow. No simple explanation fully accounts for it. Dust from distant collisions may have slowly coated one hemisphere, darkening it and triggering runaway heating that reshaped the ice beneath. Another moon, Hyperion, looks less like a world and more like a sponge. Its surface is riddled with deep craters. Ice cliffs crumble inward. The entire moon tumbles chaotically through space, unable to stabilize its rotation. Stand on Hyperion, if standing were even possible, and the sky would shift unpredictably above you. Saturn rising and falling in strange directions as the moon spins irregularly through its orbit. Gravity here does not always produce order. Sometimes it produces confusion. But the most important moons are the large ones. The worlds that manage to grow big enough for gravity to shape them into spheres. Worlds that hold secrets beneath their frozen crusts. Because Saturn's influence reaches deeper than the surface. As moons orbit the planet, gravity flexes them, pulling slightly harder when they are closer, relaxing slightly when they move farther away. Over millions of orbits, this constant flexing generates heat inside the moon's interior, a slow kneading of ice and rock, enough sometimes to melt frozen material deep underground. This process is called tidal heating, and it can transform what should be frozen corpses into something unexpectedly alive. Nowhere is this clearer than on the moon Enceladus, a small icy world only about 500 kilometers wide. From a distance it looks bright and simple. Its surface is covered with reflective ice so clean it shines like polished glass. For years, scientists assumed Enceladus was little more than a frozen relic, too small to remain geologically active, too far from the sun to support liquid water. But when the Cassini spacecraft flew past Enceladus in 2005, something extraordinary appeared in the data. Jets, plumes of water vapor erupting from fractures near the moon's south pole. Enormous geysers blasting ice particles hundreds of kilometers into space. Those plumes feed Saturn's E-ring, spreading fresh ice into orbit around the planet. Which means the ring is not just leftover debris. Part of it is being created right now, by a moon that refuses to freeze. Cassini flew directly through those plumes. Its instruments tasted the spray, and what they found changed everything. Water vapor, salt, organic molecules, evidence of a liquid ocean hidden beneath Enceladus's frozen crust. An ocean kept warm by tidal heating. Saturn's gravity pulling on the moon just enough to flex its interior and maintain liquid water beneath kilometers of ice. A frozen moon, orbiting far from the sun, quietly holding a warm ocean inside itself. The same gravity that can tear moons apart can also warm them from within. Destruction in one place, creation in another, and Enceladus is not the only example. Another moon, far larger, wrapped in thick orange haze, holds something even stranger. But that moon deserves its own attention, because Titan does something no other moon in the solar system does. It builds weather, rivers, lakes, a climate. Except none of those familiar things are made from water, and the sky above Titan glows the same soft amber color that once made Saturn look peaceful. Which is when the illusion breaks again. Because the deeper you explore Saturn's system, the clearer it becomes. The planet is not the whole story. Saturn is the center of something much larger. A collection of worlds shaped, warmed, broken, and rearranged by the same gravitational patience that created the rings. And once you start looking at those worlds closely, Saturn stops feeling like a single frightening planet. It begins to feel like a domain. Far beyond the rings, beyond the shattered ice and shepherd moons, one world dominates Saturn's outer sky. It does not sparkle like Enceladus. It does not look broken like Mimas. It sits in darkness wrapped in a thick orange haze, almost the size of a small planet. Titan. At first glance, Titan looks calm in the same way Saturn does. Soft colours, smooth clouds, a dim amber atmosphere glowing under distant sunlight. But Titan carries a strange distinction in the solar system. It is the only moon with a thick atmosphere. And that atmosphere changes everything. Because most moons are silent places, airless, frozen, exposed to space. Titan is not. Its atmosphere is 4 times thicker than Earth's, made mostly of nitrogen with traces of methane and other hydrocarbons drifting through its sky. Stand on Titan's surface and the pressure pressing against your suit would feel surprisingly familiar. About 1.5 times what you feel at sea level on Earth. You would not be crushed. You could walk, and yet the world around you would feel profoundly alien. The sun would appear weak and distant, only a small pale disk behind the thick orange smog. Daylight would look like a permanent sunset, a dim copper glow filtering through atmospheric haze. The ground beneath your feet would be cold beyond anything Earth ever experiences, about minus 180 degrees Celsius. Cold enough that water ice behaves like stone. Mountains made of frozen water, pebbles of solid ice crunching beneath your boots like gravel. But Titan's atmosphere does something remarkable. It allows weather, clouds form, rain falls, rivers flow, except none of it is water. At Titan's temperature, water is rock. Instead, methane and ethane, gases on Earth, condense into liquid. They form clouds high in the sky. They fall as rain. They carve channels across the landscape. Entire river systems stretch across Titan's surface. Some flow for hundreds of kilometers before emptying into lakes. And those lakes are real? Cassini's radar mapped enormous bodies of liquid near Titan's poles. Dark, mirror-smooth surfaces reflecting faint radio waves back toward the spacecraft. Some of those lakes are larger than the Great Lakes of North America, but they are not filled with water. They are filled with liquid methane, hydrocarbon seas resting quietly in the cold. Imagine standing on the shore of one of them. The sky above you is orange. The air is thick. A gentle wind ripples across the surface of a methane sea. Waves form, small, slow waves. If you threw a stone, if stones even exist in a world where ice is rock, it would sink into liquid natural gas. And the strangest part is that Titan's gravity is weak, only about 1/7 of Earth's. Your body would feel light, almost buoyant. Combined with a thick atmosphere, that low gravity creates an odd possibility. Human flight. With wings strapped to your arms, you could glide across Titan's skies with very little effort. The air is dense enough to support you. The gravity is gentle enough to lift you. In theory, a human could fly, but breathing the air would kill you almost instantly. Because Titan's atmosphere is nitrogen and hydrocarbons. No oxygen, no warmth, and methane vapor drifting through the air like invisible fuel. The temperature is so low that even methane behaves calmly. But if oxygen were present, Titan's skies would ignite. The moon is a frozen laboratory of organic chemistry. Sunlight and radiation break methane molecules apart in the upper atmosphere. Those fragments recombine into complex hydrocarbons. Ethane, propane, benzene. Even larger molecules forming brown smog particles that slowly drift downward like soot. Over time, that haze settles onto the surface, painting Titan's landscape with dark organic dust. The result is a world that looks eerily Earth-like in shape but completely alien in substance. River valleys, dunes, shorelines, rainstorms moving across the sky. But every familiar feature is made of unfamiliar chemistry. Water is rock. Methane is rain. Ice is bedrock. And the sky itself glows with thick organic haze. Cassini and its companion probe Huygens gave humanity its first direct glimpse of Titan's surface. In 2005, the Huygens probe parachuted through Titan's atmosphere. For 2 hours it descended through orange clouds, transmitting images back to Earth. The pictures revealed branching river channels carved into the icy terrain, rounded pebbles scattered across the surface, evidence that liquid once flowed and still flows across the moon. When Huygens finally touched down, its instruments detected damp ground, a mixture of water ice and hydrocarbons, cold and solid beneath the probe. It was the most distant landing humanity has ever achieved. Nearly 1.4 billion kilometers from the sun. And what it revealed was something both beautiful and unsettling. Titan is not just a frozen rock. It is an active world, a climate system operating in deep cold. Methane evaporates from lakes, forms clouds, falls as rain, then returns to the seas. A complete weather cycle, an alien version of Earth's water cycle running under orange skies. And that raises a deeper question. Because Titan's chemistry resembles something scientists believe may have existed on very early Earth, before oxygen filled our atmosphere, before life reshaped the planet, back when complex organic molecules floated through the sky and collected in primitive oceans. Titan may be a window into that ancient stage of planetary chemistry, a place where the ingredients of life drift through the atmosphere and settle onto the ground. But Titan is also a reminder of something else. Because this world, so rich in organic chemistry, exists only because Saturn holds it there. Titan orbits Saturn at a distance of about 1.2 million kilometers, close enough for Saturn's gravity to dominate its motion, far enough that tidal forces do not tear it apart. The Moon sits in a delicate balance. Saturn's influence stabilizes its orbit, shapes its tides, possibly even warms its interior slightly through gravitational flexing, which means Titan's strange climate, its methane seas and hydrocarbon rain, exists within Saturn's gravitational empire. The giant planet does not simply host Titan, it defines Titan. Without Saturn's gravity, the Moon's history would be entirely different. Its orbit might wander, its atmosphere might escape, its climate might collapse. Instead, Titan circles the giant planet in quiet obedience. Every 16 days, it completes another orbit. Saturn rises and sets in Titan's sky like an enormous pale crescent, glowing through the haze. And when you look back toward the planet from Titan's surface, something becomes clear. Saturn is not just a world with rings. It is the center of a network. Moons, debris, atmospheres, oceans hidden beneath ice, storm systems spanning entire planets, all held together by the same patient gravity. And the deeper scientists looked into that system, the more they realized something unsettling. Saturn's moons are not just passive objects orbiting a giant planet. They are active environments, worlds evolving under constant gravitational pressure, some broken, some transformed, some possibly harboring oceans warm enough to support life. Which means Saturn is not simply a beautiful planet surrounded by ice. It is something larger, a gravitational ecosystem. And once you see the system that way, Saturn's calm appearance begins to feel even more deceptive, because the giant planet at the center is quietly shaping everything around it. From the shattered debris of the rings, to the methane seas of Titan, to the hidden ocean of a tiny moon called Enceladus, a place where water from a buried ocean erupts directly into space. Not all of Saturn's moons announce their strangeness the way Titan does. Titan hides its secrets behind an atmosphere, but another moon, much smaller and brighter, hides them beneath the ice. From orbit, Enceladus looks simple. A white sphere only about 500 kilometers wide. Smooth in places, scarred in others, sunlight reflects off its surface so efficiently that Enceladus shines brighter than almost anything else in the solar system. Fresh ice covers much of the moon, reflecting more than 90% of the sunlight that reaches it. At first glance, it looks frozen solid, a quiet snowball circling a giant planet in the cold. But that brightness is actually a clue, because surfaces that are reflective are usually young. Impacts darken ice over time. Dust settles. Radiation alters chemistry. But Enceladus remains bright, which means something is constantly renewing its surface. Something underneath is still active. Cassini discovered what that something was almost by accident. In 2005, the spacecraft flew close to Enceladus and noticed something unexpected near the moon's south pole. A faint haze. At first it looked like a thin cloud surrounding the moon. But as Cassini passed closer, the instruments began detecting something more dramatic. Jets. Columns of material erupting from the surface. Not dust. Not gas leaking slowly into space. But powerful geysers blasting ice particles hundreds of kilometers above the moon. These eruptions were coming from long fractures in the ice near the South Pole. Dark cracks stretching across the terrain like scars. Scientists nicknamed them the tiger stripes. Along these fractures, the crust of Enceladus opened slightly under tidal stress. And through those openings, material from deep below escapes into space. Water vapor, ice crystals, salt particles, organic molecules. Cassini flew directly through those plumes. Its instruments tasted the spray. The data that came back changed how we think about icy moons forever. Because the plume particles contained salt. Not just frozen vapor, but salty ice grains. The kind of chemistry you expect when water has been in contact with a rock. In other words, Enceladus was not simply venting surface ice. It was spraying material from an ocean. A liquid ocean hidden beneath the moon's frozen crust. And that ocean is not small. Gravity measurements and plume analysis suggest a global sea beneath the ice shell, perhaps 30 to 40 kilometers deep in places, all hidden under a crust maybe 20 kilometers thick. That means Enceladus, a moon barely 500 kilometers wide, contains a significant reservoir of liquid water. But water alone is not enough. The real surprise was what else Cassini detected. Molecular hydrogen. Tiny amounts, but unmistakable. Hydrogen gas can form when water interacts with hot rock in a process called serpentinization. It is the same chemistry that happens near hydrothermal vents on Earth's ocean floor. On Earth, those vents support entire ecosystems. Microbial life feeding on chemical energy rather than sunlight. Cassini did not detect life on Enceladus, but the chemistry it observed suggested that something very important might exist down there. Energy and ocean. Mineral interaction with rock. Chemical gradients capable of powering metabolism. In other words, Enceladus contains 3 of the key ingredients scientists look for when searching for habitable environments. Liquid water, chemical nutrients, energy, all hidden inside a frozen moon orbiting Saturn nearly 1.4 billion kilometers from the Sun. The question then becomes obvious. How is that water still liquid? Enceladus should have frozen solid billions of years ago. It is far too small to hold enough internal heat from its formation. Left alone, it would have become a block of ice long before humans evolved on Earth. But Enceladus is not alone. It lives inside Saturn's gravitational system. Every time Enceladus orbits Saturn, about once every 33 hours, the giant planet's gravity pulls on it. Not evenly. The side facing Saturn experiences a slightly stronger pull than the far side. As the moon moves through its elliptical orbit, that difference stretches and relaxes the moon repeatedly. Like kneading a rubber ball, this process is called tidal flexing. And over time, that flexing generates heat inside the moon's interior. The ice shell bends. The rocky core shifts. Friction builds warmth. Not enough to melt the entire moon, but enough to keep pockets of water liquid deep below the surface. And those tiger stripe fractures act like pressure valves. As the interior ocean warms slightly and pressure builds beneath the ice, water vapor escapes through cracks. The plumes shoot upward. Material falls back onto the surface as fresh frost. Some of it escapes entirely into space. That escaping ice spreads outward into orbit around Saturn. Over time, it forms the diffuse E-ring, one of Saturn's outer rings, which means something extraordinary is happening. One of Saturn's rings is not just ancient debris. Part of it is being created right now, by an ocean erupting from a tiny moon. Enceladus is effectively leaking its interior into space, geyser by geyser, orbit after orbit. The material drifts outward, joins the ring, becomes part of Saturn's glowing halo, and all of it is powered by gravity, the same force that tears moons apart inside the Roche limit, the same force that shaped the rings, the same force that organizes Saturn's atmosphere into endless bands. Gravity here is not just destructive. Sometimes it warms, sometimes it awakens. Saturn's system contains both outcomes. Broken moons becoming rings, frozen moons becoming ocean worlds. And that dual nature is part of what makes Saturn so unsettling. Because the planet itself rarely does anything dramatic. It simply pulls, steadily, quietly, over millions of years, and those tiny differences in gravitational pull accumulate. Worlds crack, ice melts, oceans form, orbits shift, systems evolve. Saturn does not explode with violence the way we expect danger to look. Instead, it reshapes environments slowly, patiently, until entirely new conditions appear. And sometimes those conditions become places where life might, just might, be possible, which leads to an uncomfortable realization. Some of the most promising places to search for life in the solar system are not warm planets close to the sun. They are small icy moons orbiting giant worlds in the cold, worlds where gravity supplies the heat that sunlight cannot. Enceladus is one of those places. Titan may be another. Even Jupiter's moon Europa works by the same principle. Which means Saturn's system is not just a collection of frozen objects. It is a network of environments. Some broken, some evolving, some potentially habitable, all shaped by the same central force, and understanding that force required something extraordinary. A spacecraft that would spend 13 years orbiting Saturn, watching the storms, flying through the rings, sampling the plumes of Enceladus, mapping Titan's seas, and eventually doing something no spacecraft had ever attempted before. It dove directly into Saturn itself, a final descent into the atmosphere, a mission that ended by becoming part of the planet it had spent years studying, a spacecraft named Cassini. By the time Cassini arrived at Saturn, the planet had already been watched from afar for centuries, through telescopes, through brief flybys, through photographs that showed the rings and the golden bands. But distance leaves too many illusions intact. Cassini changed that. In 2004, after a journey of nearly 7 years, the spacecraft slipped into orbit around Saturn and began something no mission had ever attempted before. It stayed. Not for a quick flyby. Not for a handful of photographs. Cassini would spend 13 years moving through Saturn's system, watching storms grow and fade, mapping the rings in extraordinary detail, flying past moons again and again, as if they were neighbouring worlds rather than distant specks of light. For the first time, Saturn stopped being an image. It became a place we could study up close, and the closer Cassini looked, the less peaceful the planet seemed. From orbit, the rings lost their smoothness. Cassini's cameras revealed thousands of individual ringlets, braided structures twisting through each other, gaps carved by invisible gravitational resonances, entire waves moving through the rings as if they were ripples travelling across water. But these waves were not water. They were ice particles responding to gravity, tiny fragments adjusting their orbits in response to nearby moons. Every ripple a message from something massive passing nearby. In some places, Cassini even captured propeller-shaped disturbances in the rings. These patterns appeared when hidden moonlets, too small to see directly, disturbed the surrounding ice. The gravitational pull of a body only a kilometre across could reshape entire streams of ring particles. It was a reminder that Saturn's rings were not static structures. They were alive with motion, a system of debris constantly reorganizing itself under the planet's gravitational influence. Cassini also measured something subtle but important. Saturn's rings are extraordinarily clean, made mostly of water ice, far cleaner than scientists expected. If the rings were ancient, billions of years old, they should be darker. Cosmic dust should have slowly contaminated them. But the rings remain bright, which suggests they may be younger than Saturn itself. Perhaps only 100 million years old. That possibility carries a strange implication. The rings we admire today might not have existed for most of the solar system's history, and they will not last forever. Cassini detected evidence that ring material is slowly spiralling down into Saturn's atmosphere. Charged particles drag ice grains inward. Gravity finishes the work. Tiny fragments fall into the planet like snow. Scientists call it ring rain. Saturn is slowly absorbing its own halo. At the current rate, the rings could largely disappear in another 100 million years. In cosmic time, that is a blink. Which means humanity may be living in a rare moment when Saturn still wears its brightest decoration. But Cassini's discoveries did not stop with the rings. The spacecraft spent years weaving between Saturn's moons, sometimes flying within a few hundred kilometers of their surfaces. Each encounter sharpened the picture of Saturn's gravitational ecosystem. Titan's methane lakes, Enceladus's erupting ocean, Apophis' strange two-toned face, Hyperion's chaotic tumble. The deeper Cassini looked, the more Saturn's system felt less like a quiet neighborhood of frozen objects and more like a network of worlds constantly being reshaped. But the most dramatic phase of Cassini's mission came at the very end. By 2017, the spacecraft was running low on fuel. Without fuel to control its orientation, Cassini would eventually lose the ability to aim its antennas and instruments. Left drifting, it might eventually collide with one of Saturn's moons. That posed a problem, because moons like Enceladus and Titan might contain environments where life could exist. If Cassini crashed there, microbes from Earth, carried accidentally on the spacecraft, might contaminate those worlds. Scientists could not risk that. So they chose a different ending. A deliberate one. Cassini would dive into Saturn itself. In the final months of the mission, the spacecraft performed a series of daring maneuvers called the Grand Finale. Instead of staying outside the rings, Cassini began slipping between the planet and the inner edge of the rings. A narrow gap only about 2,000 kilometers wide. No spacecraft had ever flown there before. Engineers were not even completely sure what Cassini would encounter. Dust, hidden ring fragments, charged particles accelerated by Saturn's magnetic field. At the spacecraft's speed, about 110,000 kilometers per hour. Even a grain of sand could damage instruments. But the risk was worth it, because that region held answers about Saturn's mass, its gravity, and the structure of the rings. Cassini made 22 dives through that gap, each time plunging past the cloud tops, skimming through the invisible space between the planet and its rings, each time sending back measurements that refined our understanding of Saturn's interior. The data revealed that Saturn's magnetic field is astonishingly symmetrical, almost perfectly aligned with the planet's rotation axis. More precise than any magnetic field previously observed around a planet. That symmetry makes Saturn's internal dynamics even harder to explain. The currents of metallic hydrogen deep inside the planet are generating a magnetic field of remarkable stability, another sign that Saturn's interior operates under rules we still do not fully understand. Then came the final dive, September 15, 2017. Cassini fired its thrusters one last time and aimed directly at Saturn's atmosphere. There would be no return, no orbit, no escape. As the spacecraft descended, the thin upper atmosphere began brushing against its instruments. Hydrogen and helium molecules slammed into the hull at orbital velocity. The spacecraft started to tumble. Thrusters fired desperately to keep the antenna pointed toward Earth. Data streamed outward across nearly 1.5 billion kilometers of space. Temperature readings, magnetic measurements, atmospheric composition, every second counted. Because the atmosphere was thickening, drag increased. Cassini fought to maintain orientation. For nearly a minute, the spacecraft transmitted continuously. Then the signal weakened. The atmosphere was too dense. The thrusters could no longer compensate. The spacecraft began to spin. The antenna drifted away from Earth, and the signal vanished. Cassini was gone, destroyed high in Saturn's atmosphere, its fragments swallowed by the same hydrogen sky that had hidden the planet's true nature for centuries. The mission ended not with a crash, but with absorption. Saturn simply took the spacecraft in, just as it takes the ring particles falling from above, just as it has taken debris, moons, and fragments for billions of years. And in a strange way, Cassini's final act mirrored the deeper truth about Saturn itself. Because the planet rarely destroys things violently, it absorbs them, pulls them inward, sorts them, reshapes them. Saturn does not shout its danger. It hides it inside patience, inside gravity, inside timescales so long that the violence becomes invisible. From far away, the planet still looks the same, a calm golden sphere surrounded by perfect rings. But now we know what that image hides. Storms larger than worlds, rivers of wind moving faster than sound, moons cracking open under tidal stress, oceans erupting into space, rings built from broken worlds, and a gravity well deep enough to swallow a spacecraft without leaving a mark. Cassini showed us Saturn up close, and what it revealed was not a peaceful planet. It was a system that never stops working, quietly, patiently, reshaping everything that drifts too close. The deeper problem with Saturn is not distance. It is time, because almost everything about Saturn unfolds on timescales that human intuition was never designed to handle. From Earth, we experience weather in hours. Storms arrive overnight. Seasons change across months. Even the slowest processes, glaciers creeping, mountains eroding, still fit inside the span of a human life. Saturn operates on a different clock. A Saturnian year lasts nearly 30 Earth years, which means one season, spring, summer, autumn, or winter, can last more than 7 years. The North Pole can remain in darkness for nearly a decade. Storm systems can evolve for years before fully revealing themselves. The hexagon at the North Pole may have been spinning quietly through multiple human generations. When Cassini arrived, Saturn's northern hemisphere was still in winter. The sun had not touched the pole in years. The hexagon was barely visible. Then slowly, almost imperceptibly, the season shifted. Sunlight crept back over the horizon. The polar clouds changed color. Chemical reactions in the atmosphere produced the golden hues we see in images today. Cassini watched the entire transformation, something that would have taken 30 years to witness from start to finish. And yet even 30 years is brief for Saturn. The rings themselves may have existed for only a few 100 million years. That sounds enormous. But compared to the age of the solar system, 4.5 billion years, it is temporary, a passing phase. If Saturn had formed 10 minutes ago on a cosmic clock, the rings would have appeared only in the final few seconds. And soon enough, they will vanish. Ice drifting inward, gravity pulling fragments down, ring rain dissolving into the upper atmosphere. The halo will fade. Saturn will become a different planet. Future civilizations, if any exist in the distant future, might look towards Saturn and see only a plain golden sphere. No rings, no glowing halo, just a giant planet orbiting quietly in the cold. And they might never know the spectacle that once surrounded it. Time hides violence as effectively as distance. The solar system we see today is not permanent. It is a snapshot, a moment caught between transformations, and Saturn's system makes that clearer than almost anywhere else. Because the moons are changing too. Enceladus is leaking its ocean into space, plume after plume feeding the E-ring, each eruption losing a little more of the moon's interior water. Given enough time, that ocean will shrink, eventually freeze. The plumes will stop, the E-ring will fade. Titan's atmosphere is also temporary. Sunlight slowly breaks methane molecules apart in the upper atmosphere. Over time, methane should disappear. Unless something deep inside Titan replenishes it, the moon's lakes and rivers will dry. The skies will clear. The hydrocarbon weather cycle will collapse. Titan will become a frozen desert beneath a thin nitrogen atmosphere. Even Saturn itself is changing. Helium continues to rain slowly toward the planet's interior. That process releases heat, but it also alters the chemistry of the atmosphere. Billions of years from now, Saturn may cool further. The storms may weaken. The atmosphere may grow quieter. Every world in the system is evolving. But the most unsettling part is how slowly those changes occur. Human observation spans only a few centuries. Space exploration barely 60 years. We are witnessing only the smallest fragment of Saturn's story. And yet even within that brief window, we have seen storms grow large enough to wrap around the entire planet. We have seen an ocean moon reveal its plumes. We have seen methane seas ripple across Titan's poles. We have watched rings lose material. The system is alive with motion, but that motion unfolds across enormous stretches of time, which creates a strange feeling when we look at Saturn. The planet appears calm, timeless, unchanging, but that is only because our lives are short. Saturn's processes are not slow in an absolute sense. They are simply longer than us. Gravity never gets tired. Orbital resonances continue working. Tidal forces keep kneading moons. Atmospheres circulate. Ice fragments collide. And all of it continues whether anyone is watching or not. Which means the Saturn we see now is not the beginning of the story. And it is not the end. It is just the moment when human eyes happen to arrive. A moment when the rings still exist. When Titan still rains methane. When Enceladus still vents its ocean into space. A moment when the giant planet's gravitational ecosystem is caught in a particular arrangement. But every piece of that arrangement is temporary. Given enough time, the rings vanish. Moons migrate. Orbits change. Oceans freeze. Atmospheres fade. Saturn itself will persist. But the system around it will not look the same. And that realization changes how the planet feels. Because the scariest thing about Saturn is not the storms, not the crushing pressure, not the hexagon or the shattered rings. It is the scale of time that Saturn inhabits. A system so patient that it reshapes entire worlds without urgency. Gravity nudging objects for millions of years until something finally gives way. Moons warming slowly until oceans appear beneath ice. Fragments spiraling downward until halos fade. Saturn is not violent in the way disasters on Earth are violent. It does not erupt. It does not explode. It waits. And in that waiting, entire worlds change shape. Which means when we look at Saturn through a telescope today, we are not just seeing a planet. We are seeing a moment, a brief alignment of processes that will not last forever. A system quietly evolving around a giant gravity well nearly 1 billion miles from the Sun. And we are seeing it from very far away, which is the only reason it still looks peaceful. From far enough away, Saturn looks like the calmest place in the solar system. That image survives because distance edits the story. Distance removes the wind. Distance removes the pressure. Distance removes the slow violence that only appears when you move closer. What remains is symmetry. A golden sphere, a perfect halo of rings, a quiet planet hanging in black space. It feels balanced, almost gentle, but by now that image has begun to crack, because every layer of Saturn we have approached has revealed something different. The sky is not calm. It is a river of wind moving faster than sound. Storms can stretch around the entire planet. Lightning burns through clouds thousands of kilometers wide, and above those storms, the North Pole draws a perfect hexagon in the atmosphere, a geometric scar carved by a jet stream older than human civilization. The rings are not decoration. They are debris, a shattered body, perhaps a moon, ground into trillions of ice fragments and arranged by gravity into something beautiful enough to fool the eye. Saturn did not build those rings. It inherited the wreckage. And it keeps the wreckage moving, every particle circling the planet at tens of thousands of kilometers per hour, every orbit part of a gravitational machine sorting fragments into delicate bands. Even the calmest part of Saturn, the thin glow of its atmosphere, hides something dangerous. Because there is no surface, no place where the sky ends and the planet begins, only a continuous descent into pressure, into heat, into an interior where hydrogen becomes metal, and entire oceans of fluid electricity circulate deep beneath the clouds. Saturn is not a world you could land on. It is a depth, and the deeper you go, the less the environment cares about survival. But even that is not the deepest illusion, because Saturn is not just a planet. It is the center of something larger, a gravitational domain, Titan circling in thick orange air, where methane rain falls into lakes the size of seas. Enceladus erupting with plumes from a hidden ocean, spraying water and organic molecules into space. Dozens of other moons, each shaped by tidal forces slowly kneading their interiors. Some broken, some warming, some possibly carrying oceans in darkness. Saturn does not simply host those worlds, it changes them. Gravity pulling, tides flexing, orbits shifting. Quiet forces working across millions of years until environments transform. Moons crack open. Ice melts beneath frozen crusts. Debris spreads into rings. And every process continues with the same strange patience. Because Saturn's real weapon is not power. It is time. A storm that lasts a month on Earth might last years there. A season lasts 7. A ring system might appear and disappear within a few 100 million years. A brief moment in the planet's life. Entire oceans can form beneath ice simply because gravity keeps pulling long enough. Saturn does not rush. It does not need to. Gravity repeats. Orbit after orbit. Year after year. And repetition, over time, becomes transformation. Which is why the planet still looks peaceful through a telescope. Our lives are too short to see the system working. The storms are too large to feel violent from 1 billion kilometers away. The rings evolve too slowly to reveal their fragility in a single lifetime. Distance smooths everything. Time hides the mechanism, but the closer we have moved, the more spacecraft we have sent, the more data we have gathered, the clearer the truth has become. Saturn is not peaceful. It is stable. And stability, in a system this large, can be far more unsettling than chaos, because a stable system keeps operating. Quietly, efficiently, relentlessly. The winds continue circling the planet. The hexagon continues rotating around the pole. Ring particles continue grinding themselves into dust. Fragments continue spiraling downward into Saturn's atmosphere. Moons continue flexing under tidal stress. Plumes continue erupting from Enceladus. Methane clouds continue forming over Titan's seas. All of it happening whether anyone watches or not. Saturn's calm appearance is not serenity. It is distance made visible, and that distance hides a deeper truth about the universe. Because the most dangerous environments are not always the loudest ones. They are the ones that function perfectly. Systems that run according to rules so stable they never need to break. Gravity pulling, pressure rising, orbits repeating, energy moving slowly through enormous scales. No urgency, no drama, just physics continuing its work. Which means Saturn is frightening for the same reason the deep ocean is frightening, or the vacuum of space, or the slow drift of continents across the Earth. These environments are not hostile because they hate us. They are hostile because they do not notice us at all. A spacecraft can fall into Saturn and vanish without leaving a trace. A moon can be shattered and turned into rings. An ocean can form beneath kilometers of ice simply because gravity flexed a small world for long enough. Saturn does not act. It allows. Physics does the rest. And that is the quiet realization waiting at the end of the story. When you first look at Saturn through a telescope, you see elegance, a perfect system, a planet that seems peaceful compared to the violence elsewhere in the solar system. But once you understand the storms, the pressure, the rings, the moons, and the timescales involved, the image changes. The beauty remains, but it becomes something else. Not serenity, not calm, something colder. Saturn is not a gentle planet. It is a perfectly functioning one. And in a universe governed by gravity and time, those are often the most unforgiving places of all. At the end of all this, Saturn still looks the same. If you step back far enough, past Titan, past the rings, past the distant halo of moons, the planet becomes what it always was to human eyes. A pale golden sphere, a thin silver halo, perfectly balanced against the black. The storms disappear at that distance. The hexagon becomes invisible. The rivers of wind flatten into quiet bands of colour. Even the rings, wide enough to swallow Earth, shrink into a delicate line of light. From millions of kilometres away, nothing about Saturn looks dangerous. It looks composed, almost ceremonial. That is the strange power of scale. The farther you move from a system, the more its violence dissolves into symmetry. The same thing happens when you look at Earth from orbit. No borders, no wars, no storms large enough to feel threatening. Just a blue sphere wrapped in clouds. Distance edits the truth, and Saturn might be the best example of that illusion anywhere in the solar system. Because every detail we uncovered by moving closer has done the same thing. It replaced beauty with mechanism. The rings stopped being jewelry and became wreckage. The atmosphere stopped being calm and became a river of supersonic wind. The sky stopped being a ceiling and became a descent with no floor. The moon stopped being simple satellites and became worlds under pressure, some broken, some warmed, some hiding oceans in the dark. And all of it connected by the same invisible force. Gravity. Not dramatic. Not explosive. Just patient. Gravity does not shout. It repeats. Every orbit. Every tidal flex. Every slow inward drift of ice particles falling from the rings into Saturn's atmosphere. Every droplet of helium sinking through the planet's interior. Every fracture on Enceladus opening and closing as Saturn pulls on it again and again. None of these processes are sudden. They are quiet, and that quiet is the part we are not built to notice. Human instincts evolved in environments where danger announces itself. Thunder, fire, earthquakes. Saturn's kind of danger does not behave that way. Its storms can be larger than planets and still look calm from a billion kilometers away. Its rings can hold the remains of shattered moons and still appear delicate. Its gravity can reshape entire worlds without producing a single dramatic moment. Saturn does not need drama. It has time. Time long enough for gravity to grind objects down into rings. Long enough for tidal forces to melt oceans beneath frozen crusts. Long enough for atmospheres to build strange climates in places sunlight barely reaches. Time long enough for systems to evolve quietly until the result feels inevitable. When Cassini sent its last signal from Saturn's atmosphere, the spacecraft vanished in less than a minute. One moment transmitting data across 1.4 billion kilometers of space. The next moment gone, absorbed into the hydrogen sky. From Saturn's perspective, it was barely an event. The planet did not notice. Its storms continued moving. Its rings continued orbiting. Its moons continued circling through the darkness. Saturn simply kept being Saturn. And that is the final shift in how the planet feels once you truly understand it. The fear does not come from the storms, or the crushing pressure, or the shattered moons. It comes from the realization that none of those things are exceptional there. They are normal. Saturn is not chaotic. It is consistent. The same forces that created the rings will eventually erase them. The same gravity that warmed Enceladus may someday freeze it again. Titan's methane seas will eventually evaporate into space. the system will rearrange itself. Not quickly, but inevitably, because the processes that shape Saturn do not end. They only continue, which means the Saturn we admire today is just one phase of a long story still unfolding. A moment when the rings still shine, when Titan still rains methane, when Enceladus still vents its ocean into space. A moment when the system looks almost impossibly beautiful. But that beauty is temporary, and the planet at the centre will outlive it all. Long after the rings dissolve, long after the moons evolve into something new, long after the storms fade and the atmosphere cools, Saturn will still be there, a massive gravity well orbiting the distant sun. Quiet, patient, still pulling, still shaping whatever drifts close enough to feel its influence. And if there is one thing Saturn teaches better than any other world, it is this. The universe does not need violence to be frightening. Sometimes all it needs is time